So here we are. I'm actually doing some magnet fishing today. I don't do a lot of it, but you know, it's fun when I do it. I'm never expecting to find anything great, but I want to do this video to help some of you people out there who do magnet fishing and think that you're going to find yourself a meteorite when you're doing it. Now, this one particularly stuck to this magnet like there's no tomorrow. Check that out. And I can see what looks like a black crust on there. I see a couple bubbles, which mean bubbles are never good for a meteorite. Very rarely. The rarest of rare meteorites will actually have some holes in them like this, and that'd be a carbonaceous type meteorite. And you would never be able to really, unless it fell yesterday or maybe, let's say a month or two ago. If it fell here and fell in the water and I pulled it out as a carbonaceous with a little bit of magnetism to it, most of them aren't that magnetic anyways, then it's a possibility, but I can almost guarantee 99.9% that this is not a meteorite. But what I'll do is I'll take it home and I'll do an SG test on it just to see what it could be as far as being terrestrial. But for everybody who does magnet fish, if you think you found a meteorite in the water, you're usually wrong. I mean, the odds are 1 million to 1 that you're going to find one in the water, because they don't last very long because they'll actually rust out. Maybe an iron one, perhaps, that you might find in the water, but the thing is, it would have to fall relatively, within the last couple hundred years, because it's not going to last a long time in the water. The irons, which have iron nickel, tend to rust out a little bit more than the iron that we have here on Earth. They rust out quite a bit quicker, so then you can't really expect it to last very long in the water. So the odds of finding meteorites in the water are very, very slim. It's not a place to look for meteorites, it really isn't. Try a strewn field where the meteorites have actually fallen in the past, or a desert or dry arid area. Or if you're fortunate enough to have enough money to go to Antarctica, go nuts, because you'll find them in Antarctica. You just gotta go really far inland to find them. But anyways, okay, so I'll take this one home and I'll do an SG test just to show you how many of them you actually do get when you're magnet fishing. So I'll see you in a little bit. So another point that I want to make is, if you see all these little rocks down here, this is the only area that I scanned with the magnet. As you see right here, as I was scanning. This is pretty much the area that I found it in. There's quite a few rocks that you can see, and out of all these little rocks in this little area, that's the only one that's stuck to the magnet like that. So that's why, sometimes you really come, to a surprise. You're like, hey, this could be a meteorite, because you think it's one out of all these rocks. 1 in a million chance it could be, but it's highly unlikely that it is. So anyhow, let's find out when I get home, and I'll do the SG test and get an idea what this thing could be. Okay, so I stand corrected. I scanned a little bit further down this rock face, just near this big rock, and as I got close to it, another one hit the magnet and stuck to it really well. And it looks like the same kind of composition as the other one, but this one doesn't have any kind of a dark what you would assume might be a fusion crust, or just even a darkening probably from a blast furnace or something like that, because it's probably man-made, but I don't think it's pure iron. So that's, again, it's a strange one. I sure as hell am not convinced it's meteorite, because I know from my experience with meteorites that magnet fishing is not. Unfortunately, you might luck out. It's still fun to believe that it could be a meteorite, which, a lot of times you are. Like, I don't have any excitement to think that this is a meteorite. And if I get proved wrong by my SG test, and if it comes in the 7 to 8 range as far as being an iron, then boy, I'll have to rewrite the whole story on magnet fishing and meteorites. But I don't believe it is. And if it's a stone meteorite, if it falls in the realm of anything above from 4 to 4.5 on the SG test, it could be a meteorite, which highly unlikely, or in the palisite range. But I don't see anything that looks like a palisite on this stone. I don't see anything sticking out. I don't see any protrudements of any olivine crystals or anything like that. As far as it being an ordinary chondrite, not a chance. This does not look like an ordinary chondrite to me. It's very magnetic. It's very strong, very strongly magnetic. But okay, that's 2 of them. So I'll test them both out and see what we come up with as far as the SG is concerned on these. Cool. Still having fun. I must admit, it is fun. But at least I get to go home and do an SG test and see what it is, and doing research and just doing things like that actually helps me learn more and more about terrestrial rocks as well. So it doesn't hurt to take them home, do an SG test on them, find out what kind of rock it is, and then each rock is a learning point in your life. So you learn something new from doing something like this, and it helps you to determine what things are meteorites when you're actually walking a field and you pick it up. But it's kind of cool. I'll go home and test this one out too. Well, I can guarantee you that this was definitely something magnetic, and it stuck like a banshee. And check this out. It's a barbecue grill. So, hey, you know what? At least I'm going to be able to take something out of the water. Taking out a little bit of pollution. Iron in the water is not really a pollution. So you would think that, you know, taking this out, I'm going to be saving the environment. It's not really true because there's a lot of iron in the rocks that are normally around. There's iron ore and all kinds of rocks, and they're in the water too. So all this water is going to have an iron content. But I'm still going to take it out of the water and get it out of here because it does look like trash. But hey, look at that. Complete barbecue grill. You never know what you find magnet fishing. That's why it's fun. Okay, so you can see now that the cutting of the rocks has been complete. I decided to cut them before I do the SG test on them, just because it's a little one step easier than me doing it in reverse. So anyways, you don't need to always do that. You can actually take the rock and do your SG test before cutting it. I decided to cut it ahead of time, so I cut it ahead of time, and now I'm going to do the SG test on them so that I can at least have both results as far as the interior, the way it looks, so that you can have a good idea of how you come to determine if it is or isn't a meteorite, or if it's slag. So anyways, I'm going to start off with this piece, and it comes to 66.0. Oops. Now it changed to 65.9. It'll do that sometimes. It'll just change. You know what? I'll go with the 66.0. I'll wait again. See what happens. Just to be sure. Oh, that's, yeah, 65.9. 65.9. Okay, let's go with 65.9. So I'm going to 65.9 grams. I'll erase the other one. Alright, so that's the first. That's actually the second stone that I found, so anyways. Kind of doing them in backwards order. Alright, now here's the first stone that I found. Let's weigh this one. And this piece weighs 36.2. Okay. So what I'll do now is I'm going to put a rope on it, which I'm using dental floss. It's the easiest way. It's one of the easiest things to use. It's very thin. It won't change the disbursement in the water, so it won't change your readings whatsoever. Alright, so now what I do is I hang it by a piece of dental floss, take a glass of water for this scale, because this scale is only 2,000 milligrams. Sorry, this is only 2,000 grams plus it's got milligrams. So it can, you gotta, whatever you put on it water-wise can't weigh as much as the maximum weight of the scale, or else it won't work. So I'm using a glass, and I'm gonna hit the tare button on it. Or actually, what I'll show you is, before I do that, I'll reset the scale to 0. Okay, I'm gonna weigh the glass. 503 grams just for the glass of water itself. So on most scales you'll see that there's a tare button, so you're going to hit the tare button, which brings the scale back to 0, and now it's back at 0. So when I dunk this in the water, it's going to show displacement in grams. So here we go, let's dunk it in and see what we got. Okay, so this one is 15.3, keeps going back between 15.3. Alright, very steady. 15.3, I'm going to go with that. Always have a piece of paper towel close so you can just dry it off once you pull it out. So anyways, paper towels comes in handy. So, alright. So it's at 15.3, right? I actually forgot. Alright, so hold on a second. I'm going to redo it. I think it was 15.3. Yeah, now that it's quite a big difference. Okay, I'm going to do it again. Sometimes it's a good idea to do it a few times, because what happens, there's going to be some air pockets if it's got some holes, which this does. And again, I don't like that for a meteorite, but anyways, so some of the water has actually soaked in. So now I'm getting a reading of 14.6. 14.6. 14.6. So there you go, 14.6. 14.6. So I'll do the second one now. Have to reset the tare button, so back to 0. So let's try this one. Okay, 11.5. But what I'm going to do, I'm going to pull it out of the water. I'll put it in again. And some of the bubbles. 11.4, 11.5 now. Okay, so I'll give it a second. Let it settle. 11.5 was what I'm going to go with. 11.5. So 11.5. Alright. So now the next step, what you do is you need a calculator. And most of us will have, I'm sure most of you do, have a cell phone with a calculator on it, so that kind of makes it easy. So there's a second one. So now I'm going to do the calculations. So, let's see. Let's move this out of the way. Start off with the... Alright, so I'm going to start off with the first one. 65.9 divided by 14.6. Oh, we get a 451. So a 4.51. 51. So 4.51 on that one. Now what I'm going to do the second. So 32 point, oh sorry, 36, clear. 36.2 divided by 11.5. This is a 3.14. So 3.14.14. Okay. So what I'm going to do is I'm going to do them again, because it's always good to do it a second time just to get a confirmation. You can do it actually 3 times, and you take the average reading of the 3, which will give you a good idea, because the variations between once you dunk them in the water, it tends to change it very quickly. So let's see how much this thing weighs now that I did that already. So let's add the tare. Let's see the difference. 65.9. Okay, no, the weight's still the same on this one, so I can go with that. So I'll write that again. 65.9. Okay. And then I'll do the water right away. Hit the tare. Okay, here we go. And 15.3. 15.3. 15.2. 15.3. So I'm going to go with 15.3 on this one. 15.3. There we go. Okay. Since I already have the water on and the scale at 0, again, I'll just quickly do this one. And then I'll weigh it afterwards. Well, weighing it afterwards with the water in is not going to really help it, but anyways, let's see if this is going to change much from a few minutes ago. Okay, I'm getting 11.6. 11.6. Get some of the bubbles going bubbly bubbly. $11.6. Alright, so 11.6. Now I gotta get the weight. So now obviously the weight is going to change. There's a little bit of water that's soaked in. So let's see how much the actual weight has changed since we've done the first test. Really helps when these things aren't so bubbly, because the bubbles are what's going to absorb the water. So let me give it a really good dry. Hit the tare button on this thing again. Soak up a lot of the water that's soaked in. Alright, here we go. $36.2. No, it's actually identical to the last time. 36.2. Alright, good. So once again, I'll get the calculations. See if anything's changed. Well, something's changed on the first one, I can definitely tell. Okay. So the first one at 65.9 divided by 15.3 equals 4.30. So 4.30. That's a big difference between 4.51. So because there's such a big difference in that one, I'm going to do it again, and then I'll take the average of the 3. But anyways, let's see what the other one ended up being. So 36.2 divided by 11.6 equals 3.12. 3.12. All right. So let's do this one more time. So what I'm going to do, I'm not going to I'll weigh it because I'm going to dry it off. That looks pretty good. All right, and I get 65.9. Okay, so still identical in the weight. So what I'm going to do, I'm going to do the displacement and see where we're at. Tare button. Reason why I want to do the 3 times specifically with these ones too is with slag, if you're down the slag range, you're going to be really close. But this rock in particular, I'm going to explain why I'm doing it 3 times in a second. Okay, so here we go. I just dunked it in, and pretty consistent at 15.3. The rock is swirling around in the water a little bit. You don't have to be too concerned. I mean, you can stop the swirl and then try again, lift it off the bottom and then come back up. 15.3. Okay, well, yeah, 15.3. Okay, so there we go, 15.3. So it's identical. It's identical to what I just did. So that's 2 tests, and it still comes out to, the calculation would be the same, 430. All right, so now I'm going to explain to you about the difference. If you've seen by the beginning of the video and you saw the specific gravity on certain meteorites, it gives you an idea of where they could be at. So, for instance, the slag coming in 3.14, that's in the slag range. I mean, it's, you know, it's in that range. It didn't really alter from the you know, the 2 times that I did it, 312 and 314. That's very close. But this one, on the other hand, it kind of did in the beginning, because we got a reading of 4.51, okay, which is a little high. You'd have to go into, like, 4.5 could be an iron ore. Once you hit 4.5 and above, it could be an iron ore, so it's right on the cusp. Then after the second one, we did it again. We get a 4.30 on the second try, and then a 4.30 on the third try. So 4.3, it's closer, brings it closer into the Meteorite. I think I'm saying that right. Meteorite. Meteorites are so complicated with the names. There's Munialustias and Mesodum. That's a meteorite that was found in Russia. I mean, in Sweden. Anyways, a Meteorite. So there we go. This falls in close, really close. I don't think it is. I still think it could be an iron ore because of its proximity to, you know, being close to the iron ore, and also after I sliced it, looking into it, it still looks porous. Like it still looks very porous. There's still some bubbles, which some meteorites do have. I'd have to do a really nice polish on this thing and see, but it doesn't. I don't really see much stone. I do see more that looks like, you know, that this is more iron than stone. But once I get a good polish, I'll see if I can see any, like, carbonates or any silicates or anything like that once I get a polishing. But that's going to be on another video. So it's in both ranges. It came close to being a iron ore, 4.5, and then it came into the range of being where it could be, you know, a Meteorite. So it's a questionable still, and this will make you do some more investigation to see, you know, the possibility. And like I said in the video, I don't think that finding meteorites in the water with magnet fishing is a good way to find meteorites. The chances of this being a meteorite are still 1,000,000 to 1, even with, I don't know about 1,000,000 to 1, maybe a little less, but until I get this thing all polished and see what it is, I'm still thinking it's slag. Like, so I don't jump to a conclusion to think meteorite, and start posting meteorite. There's a lot of investigation that needs to go hand in hand when you're trying to determine if it is a meteorite, because it's not that cut and dry. So I hope this helps, and doesn't mean, you know, when you're going out magnet fishing, to have fun when you do find something that you think might be meteorite. Do this test and, you know, cut them in half. Have fun doing it, because it's all about just getting out there and having fun. And then you don't assume it's a meteorite. Just assume it's not a meteorite until you prove it to yourself that it is a meteorite, and going through many steps to do that. And I just went through a few steps, and I'm still not convinced that it's a meteorite. Alright, so take care and get out there and do some more magnet fishing, and good luck. Alright, so I'm here to say one more thing on this video. The proper pronunciation for that meteorite is Meteorite. So it's Meteorite. My bad. I'll get it straight one day. Anyways, have a good one.